A suggestion was that I was originally going to let you take that as another grade, that if it improved your grade on the, so if we're going to do that, I mean, that got changed. So I passed out some problems yesterday, said we were going to talk about them today. If you want, and you want to hand those in for possible credit, no. We could do that, we'll go over those tomorrow.
Okay.
So the people that want the credit can, from that, I'll look at that and see if that improves their grade. And the people that don't want the credit, you just go with the original grade. You had your hand up.
Will it count against us?
No,
Okay.
not if it's
Not if it, like, if it's correct, it'll be
you.
good. If you don't,
Your grade on the same type of problems. That's where I give you little snippets of code, and what do you have to do? You have to say how many steps, right? So you already have a grade on that. So your grade can't get worse than that grade that you already have.
See. All right.
So tomorrow, we'll go over those. And you'll hand them in and we'll go over those.
Okay.
If you want to. That is, you'll hand them in and if you want me to grade them.
Okay.
And I'll grade them. But we will go over them.
Okay.
But I'm only going to grade the ones that get handed in. And once I've gone over it, it's too late to hand it in, right? Okay. So that all makes sense.
As far as the test goes, the only thing that I would be concerned with is how long you're gonna make it, whether or not we'll have enough time to finish it.
Yeah, usually I don't
It's
make,
about like
Yeah,
2
they're not
quizzes
terrible.
and
yeah, it'll be about like two of the quizzes. That
So-
sounds good. I have got here for you
And then quick.
some problems on selection sort and heap sort, so you can get some idea. So obviously these won't be the problems since I'm giving them to you now, but this gives you an idea of what. Sorry. Here and here and
Much good.
there's just one guy sitting in the first row. There we go.
We should probably, we should probably message Tristan.
Boy, did you miss a lot of things. First of all, the test is going to be Thursday
Okay.
because Friday is fall break.
Oh, really?
Yeah, offered people the opportunity of coming in on their fall break, and no one wanted to do that. And
Surprising.
tomorrow, yesterday I passed out some problems with code on them, and you're supposed to count steps.
Okay.
We are going to go over that. We're going to go over that tomorrow. If you want that to kind of count as another grade, an improvement grade, you'll hand those in tomorrow.
Okay.
Okay, so that's
And you're
the
not going to
strategy.
count.
What have I just passed out here? These are questions on selection sort and heap sort. So I don't know, I might pick out one of these and ask it, and put this on the test, along with maybe one that I make up. This is supposed to give you an idea of what type of questions that I might ask. I mean, if you look at selection sort, the way the selection sort we wrote worked, what did it do? It had a procedure, but it wasn't min position, it was max position. What did it do? It returned the index of the maximum value. And then what did you do with that? You swapped that with the last position, right? And then you used, since we had a loop that ran max position over and over again. Each time we found the maximum, though, we were finding the maximum. Here's the array. Index 0, index 1. Way over here is index n. So this part of the array is filled. So the first time we run max position, we run it on all of this. And when we find out where the maximum was, what do? We swap. We do a swap. Say the max position is here. We swap this value with the n value. And then what did we do? So this was not a real hard out. So we ran max position on the whole thing the first time through. Then the next time through, we did end minus minus, and we ran, so then we were just running max position up to here, not including the last thing. So what are we doing? We've got the biggest guy here. We swapped it with this thing. And then we run max position again. We ran it on everything up to but not including this guy. So we're finding kind of like the second largest. And where are we going to put that? We're going to put that here. Okay, that was the idea. So with min position, so one question is, write the code for the minimum position. That's part A. And part B, what's the strategy now? Again, we're always trying to do things from the smallest. You want to end up with sorted from smallest to largest. Okay, from smallest to largest. So if what you're doing is finding, instead of finding the maximum, if you're finding the smallest, where are you going to do the swap? You know, say you found the minimum. You know, the minimum is here. Where does the minimum belong? It belongs over here.
Yeah.
So you'd swap here. Right. And then once you've done that, you don't want to look at it again. So instead, you now want to start from, not from 0, but now you want to start from, I guess, position 1, right? And find the minimum there. So with the max position, when you find the max, you put it at the end and shrink shrink the right-hand endpoint and run max position again. Here, though, we find the minimum. We're going to put it here, and you want to increase the left-hand endpoint. Notice that min position takes a place to start, a starting index and an ending index. And what will you be changing when you write code to use minimum? The minimum position, you'll be using the, you'll be changing the start. The start's going to be 0, then the start's going to be, then once you put the smallest thing, then you're going to start, you're going to look for the minimum between 1 and end. Okay, that's a difference. Oh, so what about heap sort? What are the two main parts to heap sort? What are the two properties a max heap has? If you've got this array, A, that you're using in heap sort, I'm looking at C now, what is the highest index? So, you know, so again, you don't use position 0. You use, so that gets thrown out in heap sort. So we're using, we go from index 1. Here we are at index 1 up to index end. So remember, this corresponds, index 1 is here, index 2, index 3, and down here it's going to be index 4, index 5, and maybe that's it. Maybe we only have 5, or maybe we have 6 things, index 6. So end could be 6, for instance. So there's this picture here, and where they actually are, which is in the array. And so what's the highest index that has a child? That's C. Given index I, what is the index of its right child? And write code to swap values in the array. So we'll talk about these tomorrow also. So I mean, I could answer them right now, but maybe it'd be good for you to remember or think a little bit about them. And maybe you could write down the answers right now. I don't know. But tomorrow we'll talk about these things. And then what will be on the test? The test will have questions like this. Maybe I'll take one of these and pull it out and actually have it on the test. The test is not going to be Friday, a week from Friday, because that's fall break. Yeah, okay, so it'll be Thursday. There will be 2 parts to the test. One part will be a written part that you do on paper. You don't get to use the computers. The second part of the test will be some code that I ask you to write on the computer. Okay. And so you'll get to see what everything is, but you'll hand in the written part, and then you can then you can use the computer to do the computer part. Okay. So is it clear what's happening here? Good. So I think what I want to do today, unless you have questions about these questions, I think what I want to do today is go back and work some more on the eval expressions. Does that make sense? We look at that. So, everything depends upon the following things that we are going to have. We have a string that has an expression in it, 3 plus 4 times 2 minus 5 $sign. And we have a integer stack that we're calling I stack, and we have an op stack. We just call it O stack. So we're stacking up. We're stacking up numbers here, and we're over here. We're stacking up operations. So that's a simple enough thing. Let's look at this. Here's the scan. We've got the scan written. I want to set up the stacks now. So notice we have two global variables here. One is the a 200, an array of size 200. That's where we're storing the input string, and we have the POS, and then the POS, that's keeping track of where are we in the string. So this is when POS is 0. This might be when POS is 1, and so on as we're going through the string. So we have a pair of so the two things then are the expression EXPR. So that's this array of size 200. 200 might not be big enough. You might have a gigantic expression, but we'll stick with 200. And the other thing is this int. Int POS, and again, the purpose of the POS is to keep. We run this thing called scan. I'm looking for one of these markers that actually works. We've got this scan function, and what scan does is scan gets the next piece. So it's going to get the 3. There's a fancy word for that. That's token. Each time you run scan, it gets the next piece of the expression. So it's going to get the 3. It's going to get the plus. And so what it does is it updates position. Position starts at 0, it gets the 3. If position starts at 1, it's going to get the plus. And so when scan runs, it gets the next piece, and it updates position. So if it's just gotten the 4, 0, 1, 2, 3, then it will have updated the position over here to the asterisk. So scan then gives us back either, so scan gives us back the operator. So it'll return the code for a plus or the code for an asterisk. Or scan returns a 1000, which means it's found an integer and it's stored the integer into variable v. So we have two things: the return value, where's that? That's, where do we use scan? I guess it's further down. We go to the end. Here's main. Here's where we get the expression. So F gets the expression out from the standard input. That is from what you type in the keyboard. And here's scan that each time it runs, it stores a value in RT. If we've got ourselves an integer, it stores in RT the value of that integer, and it stores it returns, and we put it in RT the 1000, which means that means we found an integer, and the integer is in V. So this was our first version of main. It's running scan just like we will run it before, but each time we use scan, we get one more item. If it's an integer, we put the integer onto the stack, the integer stack. If it's a operator, well, it kind of depends. It depends on what's already on the stack. So let's set up these stacks. I'll put them right up here. We're going to have a size way up here at the top. We'll have a sharp, one more sharp defined. So this is stack size. So stack size, STK, and that's going to be 100. So our stack will have size 100. And so going back to the bottom here, we're going to set up the I stack. We'll have the I stack. So that's a stack of integers. So int I stack brackets this stack size. We need to keep track of where we are in the stack as we keep putting things on. So we need to keep track of kind of like the top of the stack. So we're going to do that with an index. So int, what did we call it? We did this just the other day, but I did it on the blackboard. Anybody here take notes? Ha! Nobody takes notes.
What do you mean by the other day?
Just yesterday. Was it called I? It was called I something.
I don't know which one you're talking about.
Yeah, the I index, and I guess it was the O index. Yeah. So int I index. Start that off at -1. So this is a pair of things. And then there are 3 functions associated with this. There was the push, I push, so void I push. So we have some value that we're pushing on there. So the int in, that's the value that so we're pushing a value onto the stack. So where does the stack begin? It doesn't start at -1, it starts at 1. So we're going to do this. We're going to say I stack, so brackets, I index. Yeah, except that's the wrong value, so I'm going to put it here in front, plus plus. And that's going to be equal to n. That's the push operation. Again, this thing is all where? All of this thing is in this 201 subdirectory. So, I mean, you can type this in if you want, but it's available. And then we have the push operation. Sorry, we have the pop operation. So that returns a value. So we take a value off the stack and return it. So int IPOP. These are standard operations. So we aren't going to be accessing the stack array directly. We're going to be accessing the stack array through these operations. So we're going to have here I stack. What are we doing? We're returning I stack brackets I index minus minus. So why do we make the index go up and down? Well, when you're pushing something on, there's one more thing on the stack. And when you're removing something, you are returning, what are we doing? We're returning what's the value that's on the stack, and we are also decreasing the index. There's that, the top of the stack. So this does what? It keeps track of the index of the top. There was one more function, and that's just to report back what's on the top, but don't pop it off or push anything else on there. So that's int, and I think we called it itop. And so all it does is it returns what's on top of the stack. I stack brackets I index. So I'm not changing the index, I'm just reporting what's on the top. So we will be using, we won't be directly dealing with this, with the I index. We won't be directly dealing with that. We will be pushing stuff onto it. We'll pop stuff off and we'll check what's on the top. So we need the same thing. Okay, we need the same thing for the operation stack. So I'm going to take all this. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm going to take these 14, y, and I'm going to copy it right down below here. So we're going to have an O, but now I'm going to change it. We're going to have an O stack and an O index. Nuts. O index. And yeah, so that's fine. And we're going to have the push operation on. Okay, but we've got to change everything here. So the O stack, the O index, the O push, the O pop, popping the, and that's going to do it. And then there's going to be the O top that just returns the value that's on top of the operation stack. Okay. So we're going to be putting the operations here, we're going to be putting the integers over here. So starting off main like this is okay. Let's talk about how we do things here. And I kind of want to get you to do this because I think you're sitting there fairly passive. Say we get this is what's in the input. And we put a $sign, we tell the user here that they're supposed to put a $sign on the end. And so assuming that they did that, we're going to start pushing things. So, okay, this is the expression. What's the first thing scan's going to find? We'll just go around the room here. Scan's going to find what first?
The 3.
The 3, and that's an integer. So, so our code here isn't going to be to print out the integer. What do we need to do with everything gets put onto the stack? So this operation down here is not going to be, I'll comment it out. Because what we're going to have instead here is going to be, what are we going to do? It's an integer. Where does it belong? It belongs in the I stack. How do you get things onto the I stack? What operation do you do? We have three operations. There's the I push, the I pop, and the I top. Which operation will we do? I push, yeah. So what we'll say down here is we'll say instead of printing, we'll say I push. So that's going to put it onto the integer stack. And what are we pushing onto the integer stack? We're pushing the integer. Where is the integer? Where's the integer?
Index 1. Or index.
Yeah, that's where it is there, but once we've done the scan, okay?
Oh, it's in the expression.
Yeah, it's in the expression. What's that V business?
The value of the integer.
Yeah, so that's where this expression is a string.
Oh, yeah.
So, yeah, I've got it, but it's not a 3. It's like quotes 3, so it's the character for a 3. It's not actually a 3. Okay, so, but the V is the actual, so we're going to say I push V. So the scan, since the scan has returned that integer, remember, what is INT? If we go all the way to top, INT, that's just what scan returns. Scan returns 1,000, and so INT is just a symbol for that. Okay, so if scan returns 1,000, we're going to push that onto the stack. Okay. Now what? He's answered the question, so we're over to you. What happens now? What do we want to have happen? What have we just done? We've taken the integer and pushed it on. So what's it time to do now?
Get the next value.
Yeah, get the next value. And so that's what will happen here. If RT equals int, we will do the push, but we won't do the else, right? We do either the if or the else. So we're going to go back up and scan again. And when we scan this time, what are we going to get? We're going to get the plus, and pretty much, unless you get, what needs to happen to that plus? That needs to be pushed onto the stack, but later on we're going to be pushing and popping, and so what we do, so if RT equals that, so we're down here in this else case, and yeah, we aren't going to do the print. I'll comment that out. So that's what we did the first time. We probably have a lot to do here, so I'll put an open brace, and let's have a matching closing brace down here. So I'll put the print inside, but it's commented out. So we're going to be doing something. It depends upon two things. It depends upon which operation we've got. You told me it was going to be it's the plus, and whatever is on the top of the operation stack, the O stack. So as a matter of fact, we want to have, so over and over again, this is a major theme. We're going to be comparing the incoming operation, or the fancy term is token. We've gotten an item out of here, so we're going to be comparing the incoming token with what's on top of the O stack. Oh, there's nothing on the O stack right now, so I'm going to put a symbol there that just basically means the O stack is empty. So one of the things that you aren't going to find, inside of this expression is a sharp. So what I'm going to, so before we get this loop started, we're going to do a push. O push. So I'm pushing this onto the operation stack, the code for a sharp. So O push, quote, single quote, sharp, single quote. Okay, so yeah, here it is. There's a sharp here. So this time, the incoming is a plus, and what's on top of the stack, the O stack top is a sharp. So if you have this situation with the incoming being a plus and the O and the thing on top of the stack being a sharp, you're going to push. So down here we'll do a push. The action that we're going to take. Okay. So this is right now. This is pseudocode. So we have what? We have that the incoming. The incoming is a plus, so it's the code for a plus, and the top of the stack is a sharp, and so if we have those two things, then what action are we going to take? So the action that we're going to take is a push. So I don't quite know how to write this out. But basically, these two things determine what we do. And with an incoming plus and a O stack sharp, what we'll do is we'll do a push. What are we going to be pushing? We're going to be pushing the incoming. So there are only certain things we do. So one operation is you push the incoming. Okay? You do a O push of the. These are the ones that don't work. Yeah. So I'm thinking kind of making a table. A rectangular table. And over here we have the incoming operation. Incoming op. And over here we have whatever op is on top of the stack. Op on top. Huh. That sounds like one of those Dr. Seuss books. Well, not much, but a little. And so we're in the situation where the incoming op is a plus, and what's on top of the stack is a sharp. And so what operation are we going to carry out? We're going to carry out a push. So I'm thinking here that what we're going to have here, I want to write push. Well, we need to have something in here. So we're going to build this array where we have operations here that are on top and operations here that are the incoming. And what do we fill this with? We fill this with the operation that we're going to do. And so the operation that we're going to do right here is we're going to push the incoming. Okay, so I'm not showing you the code for that, but I'm just saying that what we're going to fill in. So we're going to have a two-dimensional array. And what we'll be doing here is to push. So this is not good code. We will write good code, but not yet. Okay, so in terms of our picture, I can show that to you. The plus is on here. And where do you? He's asleep. No, he's not.
Sleep.
Resting.
Yes.
So we just got the plus.
Right.
What's going to happen now?
Getting the next value.
Which is,
Number.
what number is it?
I can't really see.
Okay. And this is no good.
It's a 4, right?
It's a 4, right? And so what's going to happen is the value that RT is going to return is this 1,000, and so we'll do a push. That part we've already got on. So the I stack already has the 3 on it from the first I push, and now there's going to be a 4 on it, right? Next.
Are we going to add a subtraction sign?
Yeah, well, we've done the if, and so now we're down to the yeah. So I think we're over here to the asterisk. We're gonna get the asterisk. And so the question is, what do you do when the incoming is an asterisk, and what's on top of the stack now? What's on top of the O stack is a plus. So someplace else in our table, we have this place here. What do we want to do? Do we want to, when we got the asterisk, do we want to carry out this plus operation? What's the rule? The rule is that you do multiplications first, but we don't even have the 2 yet, right? So I think in this situation, we're going to be doing another push. So we'll be doing an I push, okay? And this, so I'm trying to keep track of what we've, so this is when the incoming is a multiplication, and what's on top of the stack is a plus. We're doing another I push of what? It's the I push of whatever the incoming is. And so I'll just write that. The incoming was a plus last time. This time the incoming is an asterisk. So we'll have an asterisk up here. Okay. Now what? You need to poke him. Okay. We just did the asterisk. I'm asking for very
Yes.
little here. What?
So it's been pushed to the
Yeah, the
operating
asterisk
stack.
has been
Okay,
pushed.
we've done
It's
that.
on the O stack.
Mhm.
Now what?
So now we look for the next character, right?
Yeah, we do we
Mhm.
continue doing the scan. We come back up to the top. We do the scan. We're going to find what?
We're gonna find the 2.
We're going to find the 2. So it's, again, it returns a 1,000.
Mhm.
So if RT is 1,000, and it is, we do the I push.
Yep.
Oh, nuts! You let me say that. What types of, these aren't I pushes, what are these?
Oh,
Those were O pushes, yeah. Thank you. Who said that? Very good, those are O pushes, yeah. But we've just got ourselves a number, and so we are doing an I push, and so this 2 will be up here, like that. Okay. We're back to the gentleman. Now what?
We'll pop the 2, then.
Well, wait, whoa. We do the scan. What are we going to do?
Oh, well, they'll find out that there's a minus after.
So the incoming now is a minus. I'll put that up here right under the plus. And what's on top of the stack is what? What's on top of the stack is an asterisk. So these operations appear over here. They also appear over here. So we're right here. So the incoming is, so let's write that out, one more line. The incoming is a minus, and what's on top of the stack right now is an asterisk. And I don't know, what operation do we want to do? So the incoming has what? Lower precedence. The incoming is a minus, and what's on top of the stack is a plus. So I definitely don't want to do the incoming operation. In fact, I want to do the high precedence operation. So in this situation where the incoming has lower precedence, we're gonna do basically we're gonna be doing an O pop, and we're gonna be doing 2 I pops. And we're gonna carry out an op. So when we do the O pop, what's coming off? The asterisk is. So we're going to be doing a multiplication. What are we going to be multiplying? Well, we do the 2 I pops here and here. Okay, so keep in mind that the I pop gives me the operation. So I know. Sorry, when I do the O pop, I'm getting what the operation is going to be. That the operation is going to be multiplication. but this is gonna be gone. It gets popped off, and so now what's on top of this stack is now the plus. This is now gone. When over here, we're taking this, we're doing 2 I pops, so these 2 things are gone. But we have what? We have the 2 and the 4 popped off. We store them in variables. And so the operation is multiplication. We're going to multiply 2 times 4. So we're going to, so we do the OPOP, that gives us, okay, so the OPOP that does what? It, maybe a comment here. So that's the operation that we're going to do. And we're going to do that operation on these 2 things that we just popped off, the 2 and the 4. So the next step, yeah, we do IPOP, and then we're going to evaluate. So we'll do the evaluation that is multiplying the 2 times the 4. That's what? 8. Where do all values go? They go back onto, so, and we do one final thing after we do the evaluate. We do the evaluate and we do a push, an I push. So we push back on the result, and the result is what? The result is 8. So I'll draw you, rather than messing that thing up, here's the new picture of the I stack. The 3 is still there, the 2 and the 4 are gone, and what's above it is the 8. Okay, so we popped these 2 things off, and then we did a push of the result of the multiplication. So the I stack looks like that now. We aren't quite through yet, because we really, really are committed to, well, we've got something new on top of the stack. What is it? What's on top of the stack now is a plus, and what's the incoming? The incoming is still a minus, and so this business here of popping and evaluating, pushing back on, you do that so long as the incoming has lower or equal precedence. So we aren't through yet. Okay, so the incoming. So let me put this next line down here. The incoming is still a minus. What's on top of the stack right now is a plus, right? And so we're going to do this again because the incoming precedence, the minus, is less than or equal to, in this case happens to be equal to what's on top of the stack. It's equal precedence this time. So this is when you do all of that work, that you pop the operator and do 2 pops of the, so I'm going to be popping off this operator. So this is gone. So this stack now is what? It's empty except for the sharp. Okay, great. And so the operation that comes off is a plus. Right, so the operation that comes off is a plus. And we're popping off these 2 things. So we've got the 8, we've got the 3, this stack. So the I stack is empty, completely empty. The O stack just has the sharp on it. And we're going to carry out this plus operation. So what's the result going to be? We're adding the 8 and the 3. Notice what's happening here is we've done the multiplication, we got the 8, and now we're doing the addition, just like we should. And so the addition of the 8 and the 3 is an 11. And what do? You evaluate, you get the 11, and you push that back on. So the new thing, so the I stack, this is the next picture of the I stack. It was completely empty when we popped these 2 things off. We're pushing the result back on of the addition. The 11 is going to be on there. Okay, now what? what's the incoming still? The incoming is still that minus. What's on top of the stack? What's on top of the operation stack? The sharp is. The sharp, no matter what the incoming is, so this whole column here with the sharp, so now I've got, so that would be, I want to fill in right here. Here's the minus against the sharp. So that'll be a push. So we'll push the minus. So here's, I'll draw you another picture of the op stack down here. So O stack. It has the sharp on the bottom and it has the minus here. Okay, so once you push it on, it's empty now, and what is it time to do? Now it's time to go back and scan again. Where do you? We push the minus sign on there. So we finally used the incoming. We got it onto the operation stack. So it's no longer incoming. So we're back up to the scan again. It's
So we scan 5.
yeah. So we're going to scan the next item. We're going to get the 5. That's what? That's an integer. And if we've got an integer, what do? We push it. So I don't have to look here. I only look here if I've gotten an operator. Right. So yeah. Here's the I stack, and we're out of time here. Well, we're very close to finishing. So the 5 gets pushed on. So 11, 5. So that's great. Now what? You need to poke him. Well, don't. Hello. Hi. We just did the 5. So the next time we run scan, we're going to get the dollar sign. So that's so our incoming is a dollar sign. Yeah. This time, so next, the incoming is a dollar sign. What's on top of the stack is the minus? Yeah. Minus. And so what are we going to do? So when you get to the dollar sign, you're at the end of the expression. So you absolutely have to do whatever's on top of the stack. So this is another place then. So what's on top of the stack is a minus. I'll put that right next. Here's the minus on top of the stack. So we're trying to figure out what are we going to be doing right here. And the answer is we need to do all of that junk again. So we're going to pop off. We're going to pop off the operation. Pop. An O pop. This is gone, and the operation that's coming off is a minus. We're going to do 2 I pops. And so we're going to have the 5 and the 11. Which is going to get subtracted from which? If you have 5 minus 2, what goes on the I stack first? The 5 would go on first, and the 2 would come after, right? So if you kind of think about it that way, the first thing, the thing that's on the top of the stack is the thing you're going to subtract. So so the thing on top of the stack is 5. We'll be doing an 11 minus 5. Okay. So 11 minus 5 is 6. So we pop those things off. So now this stack is empty, but we push the 6 back on. Okay. So that's what goes on. The I push then has the 6 on there, and what's left on the O stack? Well, this got popped off. We're down to the sharp. So what's the incoming? The incoming is still the dollar sign. The incoming is a dollar sign, and what's on top of the when this happens, you stop. I've gone through all of my input, I've gotten to the dollar sign, and I've done all the operations on the stack. So if we've gotten down to the sharp on the operation stack, if that's what's on top of the operation stack, and there's a dollar sign for input, well, that means we've gotten all the way to the end, so we'll just stop. And so next time through then, so the input is a dollar sign, what's on top of the stack is a sharp. When that happens, what action do you take? You stop. Okay. So we're going to have a table that we're going to fill out. The incoming is a number. What's on top of the stack is going to be a number, and we'll probably fill this with numbers. You know, I'll use 1. 1 will mean, so the number 1 will mean push. Maybe the number 2 means that very complicated thing. The O pop, the 2 I pops, the eval, and then the I push. Right. So that's what the number 2. So we'll code 2 in here, all these other places, like when you do a plus and what's on top of the stack is a multiplication, you're going to do operation 2. Okay. We need another operation for what? For parentheses. Okay, so you, I don't know, maybe that will be a 4. So we're going to fill this table out with numbers. 1 meaning push, 3 something that you do with parentheses, so we'll talk about that next time, and 4 will mean stop. So we're going to set this table up. So we'll do that next time. And you know, if you change what's in the table, you're changing how you're doing when you're changing the precedence rules. But we have a row and a column, the incoming always against what's on top of the stack. That determines what you're going to do. Okay, so I'll see you tomorrow. And